Cool, awesome. My name is Kush. I've been a developer relations engineer at LayerZero for about 4 months. Heavily focused on building out our documentation for Endpoint V2, a new product we launched on mainnet in January of this year, as well as helping developers in the community build on top of the platform. I truly believe that we at LayerZero want to make it as easy as possible to build cross-chain applications. Just because you're the best dev doesn't necessarily mean you have the best idea and vice versa. So I'm truly passionate about working on making this experience super simple for developers to use. So let's dive in. After the advent of Bitcoin and Ethereum, I think we have like a new chain every single day, right, here in this space. Why do we have so many chains? Developers and users want to make trade-offs between security, speed, and cost. And they want to choose their chain based on these three trade-offs. Developer A, building on Polygon, may want to optimize for speed and cost, and their users may not care too much about security, whereas developer B, building on Ethereum, may have more institutional clients who only care about security and don't necessarily care about the cost they have to spend for a transaction or how long it takes, as long as it's finalized on mainnet. But what we found is developers are starting to use multiple chains when deploying smart contracts. 34% of all crypto developers worked on more than one chain in 2023, and 8.2% of those developers developed on 5 or more chains. I think the reason that this is because developers want to tap into new user bases. They want to put the onus on the user and give them the opportunity to really use the chain they want and get access to their application. At LayerZero, what we want to do is create a global ledger to connect all these disparate networks and allow developers to use uniform contract standards that they can inherit on every chain LayerZero has an endpoint on, and deploy contracts seamlessly, wire them up, and begin cross-chain communication. Stepping back a bit into the cross-chain ecosystem as a whole, what we've seen is that a lot of bridge providers and cross-chain protocols have monolithic bridge security. What this means is that they have a single source point of failure and a set of security assumptions that developers and users need to inherit. And when all of those developers and users inherit the same set of security assumptions, it creates a single source point of failure. And when a malicious actor comes and exploits that protocol, all of the money, all of the developers, all of the users are at risk for exploit. And it's clear that this is an issue because the amount of funds lost in the 5 largest exploits in the blockchain industry, 4 out of 5 are related to monolithic bridging networks. So this is a clear issue in the industry, and we want to fix that. How do we fix that with V2? Going back, we said developers and users make trade-offs between security, speed, and cost. What if they could do that for cross-chain as well, right? So what you see in the middle here is what we call a security stack. It's a set of decentralized verifier networks that independently validate cross-chain transactions. So we have DVNs integrated currently with us, Google Cloud, Polyhedra, Gelato, Nethermind, LayerZero Labs as well. And developers get to choose from this set of DVNs what they want to inherit in their security stack. They get to make their own set of security assumptions and don't have to rely on a third party like even LayerZero Labs to make those security assumptions for them. This way, when one DVN in a security stack gets hacked or a malicious actor exploits it, developers can still rely on the other DVNs in their set to validate the right message, and message transaction flow would be blocked in this instant until the developer can interchange that DVN with another. And they can do this seamlessly without having to redeploy their contracts. All right, taking a step into what our Omnichain technology stack looks like. We have 2 contract standards that are audited and verified by LayerZero Labs: Omnichain Fungible Token and Omnichain App, OFT and OAP. And these sit on top of the communication layer. They're contracts that developers can inherit and then write, send, and receive logic on top of. OAP and OFT communicate with the LayerZero endpoint, which we deploy on every chain that we support. And this endpoint serves as the communication center. It's another contract that's deployed on every chain, and it handles sending and receiving messages on these chains. Finally, we have a message library, which is represented here in green as the custom configurations you want to set for your OAP as a developer, OAP or OFT. And so the endpoint, how this works is that an OAP will send a message to the endpoint. It'll tell the endpoint, hey, I want to send this message cross-chain. The endpoint will then call upon the message lib to verify the custom configurations of the OAP and make sure that that message is true to the configurations that the OAP has set, OAP or OFT, sorry. And then that endpoint will then send that message to the security stack. Now each DVN in the security stack independently validates the payload that is sent with the message. So all of the instructions that are customly coded by the OAP. And then each DVN will pass that Keshek hash of that payload to the receive side's message lib. And here, the message lib will verify the Keshek hash of every single DVN, make sure that they all equal each other, and then commit verification to the endpoint. Now that the message is verified, it can be executed on destination by an executor. And this is also interchangeable by developers. So if you wanted to develop your own executor, you could. We provide an executor by default at LayerZero Labs, and I'll go a bit more into that in a minute. So yeah, let's dive into the custom configurations you can configure as a developer. First is block confirmations on send and receive side. Higher block confirmations likely leads to more security, but will take longer for a transaction to pass. The security stack, the set of DVNs that you as a developer want to inherit. And diving a bit more in here, we allow for X of Y of N authentication, we call it. If I wanted one required DVN and two optional DVNs in my security stack, one of which I needed verification for in order for a message to pass, so 2 out of 3 with one required, I could do that. I could also have a set of optional DVNs with a threshold of 2, like 2 of 4, and no required DVNs. And I only care that which 2 verify that message first. So we made it super configurable in this way. In addition, as I mentioned, the modular message executor. This handles execution of messages on destination, and there's different options and gas settings you can set within the executor when handling this message logic. So an LZ receive option is something you pack into your set of instructions, your message on source, and then on destination, the executor unpacks that option and reads how much gas you want to use in your receive side logic, as well as if you want to transfer native currency in a message.value on your receive side. And LZ receive is the way I think of it is kind of similar to a receive fallback when you're sending money from contract A to contract B. That receive fallback can have any arbitrary logic associated with it that a developer wants to execute. Similarly, LZ receive can have that custom logic built into it as a function on your OAP. I'll dive into LZ Compose a bit because it's a bit more complicated and one of the coolest features, I think, of V2. But native drop option is also pretty cool. You can airdrop any amount of native gas or native currency to a destination contract or externally owned wallet. In LayerZero V1, we had ordered delivery by default, ordered execution of messages, which meant that if nonce 1 was successfully executed and nonce 2 was not successfully executed, but it was verified, nonces 3 and 4 could not be executed until nonce 2 was retried as a stored payload and executed. And what we found is that this blocked off a lot of messages, message flow, because developers would have to retry that payload before message flow began again. By default now in V2, we allow for unordered delivery. So messages still need to be verified in order to maintain the integrity of the system, but they can be executed out of order. So if nonce 2 is verified but not executed, nonces 3 and 4 can still be executed on destination. So it doesn't block that message flow from stopping. And developers, what they would have with order delivery is they'd have a backlog of all these messages that are not executing because of that reason. Max message size as well is something you can configure. How big a developer wants their maximum message size to be for users when they're sending a payload cross-chain. And finally, message composability. This is one of the coolest features, I think, in V2. Obviously, just my opinion, but what it allows you to do is break out receive logic into separate atomic chunks. Before, if you were to bridge and swap, say, 10 ETH from ETH to Arbitrum, and then swap that ETH for Arbitrum on destination, if your swap failed, your bridge would fail as well, because that's one atomic transaction. Now with V2, you can break that logic up into separate atomic chunks, such that if your swap fails, your bridge will still work, and your funds will remain on destination, and you can retry that swap later. This, I think, can be used for a whole variety of use cases for both OFT and OAP. But I'd love to hear your guys' thoughts on that after I finish up. So how do token transfers work in general, right? Pretty simple. You're just decrementing a balance on a source contract or a wallet and incrementing that balance on a separate account or contract on one chain. In cross-chain transfers, it's pretty similar. We have a debit and crediting system where if user A sends 100 OFT tokens to user B on chain B, what will happen is those tokens are debited from their account and then burned on source, and then minted on destination and sent to that user account on chain B. So yeah, that's how we build Omnichain fungible tokens on top of Endpoint V2. Endpoint V2 sits as a generic messaging layer, and OFT sits on top of that, OAP sits on top of that, to do anything really that you want, custom logic with LayerZero. Cool, so I'll stop here for questions and then show a little code snippet on how you could build your first OFT.
Any question?
I think a lot of people tend to think sometimes they confuse LayerZero. They're like, oh, it's another blockchain, right? It's another chain. But kind of what you showcased today, it's just a smart contract protocol, right? So when you're adding LayerZero to a new blockchain, is it simple as just deploying that smart contract, the LayerZero smart contract onto that new chain, and then it's cross-chain compatible, or is there a little bit more to it?
Yeah, so currently we deploy endpoints, right? So anytime a new chain wants to work with us, they usually hit us up. We deploy an endpoint for them, and once that endpoint and message lib are deployed on that chain, anyone can interact with it, right? And anyone can plug it into any of the other chains that we are integrated with, that we have endpoints on. So it's all about having that endpoint on that destination, or on that, yeah,
Is there
chain.
plans to make it like a permissionless process in the future?
Potentially, yeah.
Cool. Any other question?
Yeah, I'm just wondering if there's any like economic guarantee that if a message is sent, it will actually like arrive on the target chain. Like, do you guys have like a slashing mechanism or anything like that?
Yeah, so that's more with Stargate, I would say. Stargate guarantees finality instantly, and through the Delta algorithm, it manages liquidity on every chain in a very nifty way. I would really suggest looking at the Stargate white paper on how our co-founder figured that out and managed liquidity on many chains, because that is a significant problem, and it's not easy to solve.
Another question? Okay.
Yeah, how's LayerZero making money off of this? Like, do you guys collect fees on like message transfer?
Yeah, so LayerZero Labs is a entity that provides microservices, like, for example, the executor, right? We have our own DVN. Any DVN can plug in permissionlessly and make fees off of cross-chain transfers, right? If your DVN has a high amount of security and a high amount of trust, more users and developers will use that DVN, right? We have a DVN, we have an executor. Every part is permissionless though, and anyone can swap in or swap out that executor. So we at LayerZero Labs compete with other executors, DVNs, and provide those microservices.
So basically, you develop the protocol and also provide like the node infra, and like, do you actually get paid for doing like the node infra?
Yeah. Anyone who wants to plug in can get paid through providing that node infra.
Other question?
Can you give like a TLDR on like the major differences between LayerZero-like services and then chains like Analog coming along?
I haven't heard of Analog, but sure. And you want a difference between like endpoint V1 and V2 as well, kind of? Or just like the protocol versus, so the protocol essentially is like a message passing layer, right? Those smart contracts are immutable. They're already on chains, right? So we at LayerZero Labs can't change those contracts, right? That protocol sits, and every part of that protocol can be interchanged by a developer. The executor, the message lib is append only so that updates aren't opted into by the entire, everyone who's developing on it, because that would create a source point of failure as well for malicious exploits. LayerZero Labs is what provides those microservices, as I said, like the executor, the DVN, as well as pre-crime we're starting to work on, which is a way of testing your send and receive side message passing locally before that actually sends cross-chain.
And like, which piece of this today is like centralized? And do you have thoughts on like decentralizing, you know, like whether it's like wardens or I don't know what they're called with LayerZero, like over time?
Sorry, I couldn't hear the last part.
Like
Decentralizing what?
yeah, like which piece of LayerZero and like bridges today, like and I don't know how LayerZero works. If they like wardens at like certain parts, like bridges of the bridge or anything like that, and like thoughts on decentralizing that over time, like how, like what's like the approach or how are you guys thinking about it?
Yeah, how we think about decentralization is the idea that every part, every microservice that we provide is competitive, right? Our executor, at LayerZero Labs, we think our executor is like the best. It's very hard to develop an executor, but you can compete with us and plug in your own executor. And if developers find that your executor is better than ours, you can permissionlessly do that, and developers can permissionlessly interchange that executor. We at LayerZero Labs provide a DVN, decentralized verifier, and anyone who provides a decentralized verifier can charge their own fees and developers who plug into that can get they pay those fees along with their source and destination gas, right? So that's also a competitive thing, right? Who's the best DVN, right? And different DVNs are using different marketing strategies and starting to do that to get developers to use their verification mechanisms. So each part's permissionless. Everything's permissionless in the system.
Another question?
So when I'm choosing a DVN, is that baked in at like the deploy time at the smart contract, or is that like updatable? Like say for example, I really like one DVN, but then I want to change. Is that like reasonable to do?
Yeah, absolutely. You can, once you deploy your smart contract, you can change your DVNs in the message lib at any point. So like you said, you want to use one DVN. Now what we're starting to experiment with is like DVNs for different amounts of value. So like if I'm sending 1 ETH, I want to use this set of DVNs that may assume a lower amount of security. And then if I'm sending 100 ETH, I want to use a different set of DVNs in my OAuth, maybe 10 or 20, because that's a large amount of money and you want more security for that. So there's a lot of custom logic that we're starting to experiment with, and seeing that in the developer community is also really cool.
Someone else? We good? Okay, we're good.
Cool, awesome. I'll dive into some code example right now. Just bear with me. I just want to show you guys how you can like spin up an OAP or OFT in really simple steps, I think. So if you guys have an ID, feel free to pull it up. I'll create a new folder here. I'll call it LZ EVM OAP 8. Yes. Oh yeah, for sure. How does that look? Just trying to pull up my terminal. There you go. Okay. First command you want to run is npx create lz OAP. at latest. You get to choose between OFT and OAP. I'll do an OFT for the sake of this demonstration, and I'll use yarn. What happened here? Oh yeah, so make sure you're using NVM use 18, node version 18 or higher, and I'll try that again. Yeah, the dependencies take a bit to install, so if there's any other questions you guys have, happy to answer them right now while the dependencies install for this. But basically what this is going to do is set up your OAP or OFT, and you'll be able to deploy contracts really seamlessly after this, as well as wire them together. What wiring kind of means is setting peers. So in OAP, we have a set peers function. And what that set peers function does is to make sure that a destination OAP receives a message and accepts messages only from the source OAP. If I have many different chains and many different OAPs deployed, I only want to make sure that those OAPs on the receive side are receiving messages from my send OAP and no other contract address. So now that okay, cool. We're all set here. I'm going to CD into here my LZ OAP. I'll open this up and show you what the different files here are like. First, your env file, have to put in your private key or mnemonic. This address doesn't have any mainnet funds, so don't try and rug it, but and switch that to a .env file. Everything is already plugged into your deploy script. So a couple of things here to note. hardhat.config.ts checks your private key or your mnemonic and starts your hardhat environment. And any networks that you want to add, you can add here. We have Fuji, Mumbai, and Sepolia here by default, but you can add anything you want here that has a LayerZero endpoint. So if I wanted to copy ARB-SEP, for example, I can just name it here and then add the ARB-SEP endpoint as well as the URL. LayerZero.config.ts sets up the wiring and deployment of contracts. So like I said, with set peers, each connection is located here on line 31. So these connections help you wire up your contracts, Fuji to Sepolia, and it's like n squared for every new chain that you add, right? So if it's just 2 chains, then I would just need Fuji to Sepolia, Sepolia to Fuji. When you add another chain, it becomes 6, and then 4 becomes more and more and more, right? Then you have a mock OFT here. My OFT inherits OFT. And then you can plug in any constructor logic you want in your myoft.ts for naming that OFT. These are constructor args, the endpoint address, the deployer, who's the owner of the contract, as well as the name and symbol. So now I'm going to try and deploy my contracts. Hopefully I have enough gas. So you get to choose which chains you want, and like I said, when you add those chains to your hardhat.config, they'll show up here as well. So I'm going to deploy to these 3 chains. Use the script tag myoft. no. What error do I have here? Name deployer account. Let me just save everything. Try again. .env? Got to save it, right? Yeah. Cool. Now they're deploying.
So that just deployed to 3 different test networks?
Yeah. So it's deploying now. The address for Fuji just showed up. The address for Mumbai just showed up. And yeah, Sepolia showed up too. So all those addresses are now deployed on testnet. Let's check one out and see for sure. There you go. Contract was created 21 seconds ago. And now what I'm going to do is wire these contracts together so that set peers is called on every contract and cross-chain communication can be enabled. I have my function here. And by the way, all this whole walkthrough can be found on our docs. I'll just pull them up right here. docs.layerzero.network. If you go to the developer section, and then LZ OAP quick start, this entire create LZ OAP flow will walk you through anything you can do with LZ OAP. And this includes custom configurations like your DVNs. If you want to add custom logic to your OFT, how many tokens you want to mint on every chain. We'll explain all this here. So now I'm going to run this OAP wire function to call set peers on every contract. You can also preview transactions, but I won't for the sake of time. And this will wire all the contracts by calling set peers. And what's important to note with set peers that a lot of people kind of forget is that you have to set peers on both source and destination, even if you're sending one-way messages, right? The source OAP will check that your peer is set for your destination, and then when your destination receives that message, it'll also check that that message is indeed from that source. Any questions? Cool. It's probably a good thing.
Does different finality on different chains affect, like, when you're deploying it to all 3 at once?
It just deploys it one by one. Right. Yeah, we have a function in the back, a hard hat task that loops through and deploys them one by one. You could also do that using create3 as well. There's logic for that in there. So now your OAP is configured, and I will see through here that set peer was called twice on this contract for each other contract on Mumbai and Avalanche, and now you're set for cross-chain communication. That's all I have today. So thank you all for showing up and appreciate it. Yeah.